another session of transportation engineering. As we all know that we are discussing traffic engineering, and in last session we have learned about basic capacity. What is basic capacity? What is the equation of basic capacity? Then what is traffic capacity and how it can be calculated? Now we have also learned what is time mean speed, what is space mean speed, what is time headway, what is space headway. So in this session, we are going to cover the practical examples of those topics. So let us move towards the topic. In this session, we are going to cover the topics such as the example based on various kind of speeds, means time means speed, space means speed. We are also going to cover the topics related to time, headway, space headway, etc. So let us learn the first example. This is the statement of that example. Stay focused. What is written over here is the vehicle passes 1 kilometer length 1 kilometer length of road is given in 1 minute, 2 minute, and 3 minute time respectively. And we have to find what? The time mean speed and the space mean speed. We have to find time mean speed and space mean speed. Now, we all are aware with the basic equation that we have learned in our school days, that speed is equals to distance by time, means v is equal to d by t. So what we have to do is we just have to put the values which are given over here in this particular equation. For first vehicle which is carrying 1 minute of time and 1 kilometer of load, V is equal to D by T, where D is equal to 1 kilometer and T is given over here in minutes, and this is, we have to convert this in kmph, so we will divide it by 60 minutes. So it will be 1 by 1 by 60. So V is equal to, what I have done, let me explain this once again. V is equal to d by t. D is equal to 1 kilometer. Here it takes 1 minute and 1 hour has 60 minutes. So it is 1 by 1 by 60. It will be 60 kmph. Such as for second vehicle, it is 1 kilometer only, but it is taking 2 minutes by 60. So it will be 30 kmph. And for the third vehicle, it is taking 3 minutes, so it will be 30 by 60, so it will be 20 kmph. So for first vehicle, it is 60 kmph, second vehicle, it is 30 kmph, and third vehicle, it is 20 kmph. Now we have to calculate time mean speed as the first part and the space mean speed as the second part. So let us calculate the first part, that is the time mean speed. We have learned the equation of time mean speed, that it is the summation of speed divided by total interval. So what we are going to do over here is we have total various kind of speeds which are given over here. What we will do over here is we will take this as 60 plus 30 by 20. We have three speeds and we have three intervals. So the time and speed over here will be 36.7 kmph. And if I have to calculate about space mean speed, then it is the inverse of this. So it will be 3 divided by 1 by 60 plus 1 by 30 plus 1 by 20. So it will be 30 kmph. So the time mean speed is 36.7 kmph and space mean speed is 30 kmph. So this is how we can calculate the values. Now what I will do is, another particular section is given over here, that spot speed studies were carried out at a certain stretch of a highway, and the data collected are summarized in the table. Spot speed study, we have learned that spot speed study means instantaneous speed calculation. So spot speed studies were carried out at certain location of highway, and they have collected the data in the form of speed range and in the form of number of vehicles. That 12 vehicles were crossing the stretch at the speed of 0 to 10 kmph. 18 vehicles were crossing the section of road at the speed of 10 to 20 kmph, and such as, this is how the particular data is collected. Now what we have to do over here is we have to draw frequency distribution curve and we have to calculate modal speed, median speed, time mean speed, design speed, speed for traffic regulations, standard deviation and coefficient of variation. Let me verify the values once again. What are the values? For 0 to 10 it is 12, for 10 to 20 it is 18, then it is 68, it is 89, it is 204, it is 255, it is 119, 43, 33 and 9. So the first thing that I will do in order to calculate this example is I will make table like this. I have already values of, I have this column and I have this column. See, number of vehicles is called as frequency F. So we have table number, column number 1 and column number 3. So these two things we are already having. What I will do, so I have this, I have already this. I will first do the calculation of mean speed. 0 plus 10 by 2, 10 plus 20 by 2, 20 plus 30 by 2, 30 plus 40 by 2, 40 plus 50 by 2, 50 plus 60 by 2, 60 plus 70 by 2, 80 plus 70 by 2, 80 plus 90 by 2, 90 plus 100 by 2. So this is how I will get the mean speed by the provided range. Fine. So it is too easy to calculate. Now, what I will do in the next part is I will calculate the frequency, such as if total 850 vehicles are there, right? And out of that, 12 vehicles are moving with this speed, then out of 100, how much will be there? So it will be 1200 by 850. If you calculate this, you will get the value as 1.41. Just like for this also, how I will calculate this for 850, if the frequency is 18, then for 100 it is how much? So it will be 1800 by 815, I will get it as 2.12. And for all the values given over here, I will calculate the values of frequency and these are the values in the percentage. And if I add on these values, totally at the end I will get the sum of 100%. So this is the verification that the values that I have incorporated or I have calculated are correctly done or the calculations are done correctly. So I will do this first, then I will do this. Then I will calculate the cumulative frequency. Means what I will do, I will put 1.41 over here, 1.41. Then I will calculate this to this and I will put the value over here. Then I will calculate this value over here. Summation of this and this. Then 11 plus 10.47, this. 22 plus 24, 46. 46 plus 30, 76. 76 plus 40, 90. 90 plus 5.06, 95.06. This plus this plus this. And ultimately I will get the cumulative frequency like this. And this is the multiplication of f and x. Means this is x and this is f. I will multiply both these things. 12 into 5, this is 60. 15 into 18, this is 270. Multiply this value, I will get this. So ultimately, I will get the values by multiplying f into x. So this is how the calculation will be done, and this is how first we will create this kind of table, and at the end I will do the summation of all these value and it will be 42970. Let me repeat once again. What I have done is I have given this value, I have already given this value. What I will do, first of all I will calculate the mean speed, then I will calculate the percentage frequency, then I will calculate cumulative frequency by adding this value. And then I will multiply the column of f, this with this, and I will get this value, and ultimately I will do the summation of this value. Now after calculating this table, after creating this table, what I will do is I will plot the graph of cumulative frequency versus speed in kmph. I have speed in kmph already, I have cumulative frequency also, so I will put this value. So that graph will be like this. In this axis, I will put cumulative frequency in form of, let us take, it is 10, it is 10, 20. Just wait for a minute. I have to remove this. This is cumulative frequency. This is 30. This is 40. This is 50, 60, 70, 80, 90 and 100. Pardon me for this, but you can consider this because this is the what I can say assumptive sketch. And on this axis, I will put the value of speed in kmph. So I will put the values such as 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Now, what I will do over here is first I need to calculate the modal speed. Now what is modal speed? Modal speed is the speed having maximum frequency. So what we will do, we will go back to the table and we will see where the maximum frequency is lying. So this is the frequency table. You can see the maximum frequency is at 255 and it is at the speed of 55. So I will plot this value over here and I will call it as modal speed. So I have modal speed of 55 kmph that we can get from the table itself. And the second thing is the median speed. What is median speed? It is the 50th percentile speed. Now, how do I calculate the 50th percentile speed? How do I calculate the 50th percentile speed? So what I will do, this is the cumulative frequency curve, this is 50th. I will plot this. First of all, I will have to plot my graph as this because I have already calculated the value of cumulative frequency. And if I plot it as over here, then I will get it the 50th percentile speed as the 47 kmph. You can do it by plotting this cumulative frequency and speed graph. Here I am just trying to explain the things, that is why this kind of things is happening, but I hope you can get the understanding. The major important thing is this concept that what is modal speed, what is median speed, medial speed. Now the third is about time mean speed. So it is the arithmetic mean speed. It is also called as x bar. So it is the summation f of x by summation f. We have already calculated the table value 42970. We have summation f as 850. So it will be 50.55 kmph. Then we will calculate the fourth part, that is design speed. We can get the design speed. We have plotted the values from 10 to 100 over here, 10 to 100 over here. Let us assume that we have plotted the values and we have got the graph like this. Now we know that the design speed is also called as 98th percentile speed. So at the 90th percentile speed, what I will do, I will just try to extend this line and check that where it is intersecting, and I will join the intersecting point over here, and let us assume that I get the speed as 84 kmph. Here it is 84 approximate. So our design speed will be 84 kmph. Now the fifth part is about the calculation of traffic regulation. Now to know the traffic calculation regulation speed, we have to calculate the safe speed as 85th percentile speed. So what I will do, I will check that this is 80 somewhere over here, this is 90. I will extend this line, put intersection point over here and extend this line and get that this is the 60 kmph speed that I have got as the 85th percentile speed. So 85th you will be getting as 60 kmph. You need to do this by referring the Rethalia publication, Atul publication. This example is already given over here. I cannot put the exact values, otherwise you will not be able to understand the concept. If I directly put the photos by clicking the photos from the book and put it in the slide, then you will not be able to get the concept. So just go through the concept. You can calculate this thing. Then another thing that we need to calculate is the standard deviation. Now, how can I calculate the standard deviation? So it is the equation for standard deviation is percentile 85th percentile speed minus 15th percentile speed divided by 2.07. We have already got the value as 60. We have got it this value as 2. This is 30. How can we get this value? We can get this by, this is somewhere over 30. This is the graph. So what I will do, I will put the point over here and extend this value, and I will get this speed as the 30th percentile speed. So this is somewhere between 14.49 kmph. Then the last thing is about the coefficient of variation. The equation for that is 100 by x bar. So it is 100 into 100 into s into x bar. It is s. So it is 14.49 and divided by, we have already calculated the value of x bar, which is 15.55. So it will be 28.66. 100 into 14.49 divided by 50.55, it will be 28.6. So this is how we can calculate the value of this particular thing. And the another example is very easiest example. It is, the statement is given over here is the number of vehicles passing at the section of 1 over which is given. 40 cars are passing, 35 buses are passing, 20 trucks are passing, 15 tractors are passing, 60 motorcycles are passing, and we have to calculate the total traffic flow. So we have type of vehicles already given, we have number given, we know the PCU. You have to refer the table that I have covered in the last session. What I will do, I will multiply both the things over here. Number into PCU, number into PCU, number into PCU. And ultimately I get the total value of traffic flow as 250 passenger car unit per hour per lane. So these are the basic examples that I have incorporated in order to make the clear understanding of the concept. I hope you have gone through the example. Put your individual notes on that and try to calculate these examples on your own. Try to understand the concept thoroughly. Thank you so much for attending, paying the attention. Thank you.